So looking the jet theme, now you can just adding up the two other Z Thevenins to find the Z1 plus Z2 with these two parallel ports Z1 and Z2, and then you can merge this so that they can series and you can find out the Z Thevenin. In case of finding the V Thevenin, first of all, see there applied voltage 120 volt 75 degrees, and two currents will be branched into other parts, in this part and also in this part. So these two currents is divided by the voltage divided by this 8 minus 6 J6 you can see here, and 4 plus J12 as you can see here, and this V1, if it is the node voltage will be V1 and this node voltage will be V2. So V1 minus V2 you can easily get V Thevenin. From here you can get yes that is the V Thevenin 4I2 minus 6J6I1. Just calculate it to find out this. It's not only this, the two voltages will be applying KVL around this port. Around this port, you can see this port V1, V2. This voltage is V1, that is V2, and applying KVL through this, that will be V Thevenin plus V1 plus V2. It's like this. Minus plus minus. All the voltage will be in KVL format in this loop here. So you can find out by this by applying the KVL, Kirchhoff's voltage law. Now you can find out the voltage from here. V Thevenin is minus 4 I1 I2 and plus minus J6 I1, and first of all you will find out the relationship like this. Just find out the V Thevenin, calculate it as usual, as you can see here, then you can find this voltage here. So now just looking behind in that source, just the practice problem, find the Thevenin voltage. First of all shorten up this voltage source, then find out the Z Thevenin through looking from here. If it is shortened out, so this is the parallel port, and first of all find out the Z2, that will be Z2, and the Z2 will be parallel of this two, the 6 ohm plus 2 J2 ohm and the J minus J4 ohm. These two parallel ports will be solved by this. If it is Z1, if it is Z2, can parallel, make it parallel, and then another Z2 will be this. So that will be series. So Z1 plus Z2 you can easily find out Z Thevenin, that will be additive as it is series. Z1 plus Z2. After that, finding out this equivalent circuit Z Thevenin, if you want to find out Z V Thevenin, so looking at that port, first of all applying Kirchhoff's voltage law or apply voltage divider rule, you have to find out the voltage across this part. After finding out this voltage will clumped in that part, because as it is an open circuit, there will be no current will be flow here. There is no current will be flowing here. So the voltage across the minus J4 ohm is equal to the V Thevenin or VAB. Okay, so that is a basic circuitry that we will solve. Now looking at another Thevenin equivalent circuitry, as a current source has been given here. So to find out V Thevenin, we have to apply Kirchhoff's current law at node 1. So that's the node 1, that's the node 2. They are applying the nodal analysis, but you can make it quite quite similar or quite solvable. When you see this kind of dependent current source, you have to first add independent current source across it. Okay, while you are removing these current sources, you have to apply these sources here, and always add these sources, not to just open up these sources. So that's a different type of problem solution about the dependent sources. We will come across and understand and learn this with brief details in our next lessons. But stay tuned to know this kind of two other problems that I have told you before. There are some lessons are too, but these are the basics of Thevenin equivalent circuit. First of all, find out the Z Thevenin, then find out the V Thevenin. Okay. So we will stay tuned. On the next lecture, we will understand the Thevenin theorem across the dependent sources, as I have discussed here, but I will give you an elaborative understanding on this. And if you know the basic of Thevenin equivalent circuit, you can easily calculate the Norton's theorem, because the Norton's theorem is quite equivalent to Thevenin's theorem, but the difference is that Norton's theorem is the current source theorem and Thevenin's theorem is the voltage source theorem. Just like this is the very much short and narrow difference between these two. So thank you very much for being with me in these lessons. I will merge up all the lessons together, and you will be understanding and I will give you some explanations later on Thevenin's equivalent circuit. Thank you very much for being with me this week. So stay tuned, stay healthy, stay blessed.